Yes, welcome back class to the second part of this lesson. In the first part, we were looking at what we did look at in the last lesson in a summary. When you expand the term a plus b, a binomial term, by powers from 0 up to power 4, what do you get? And we saw what we are going to get in a summarized form to be that. Then you notice a certain pattern in terms of the coefficients that are written the expansion. We saw that if you expand to power 0, the number of coefficients will be 1. Expand to power 1, you'll be having 2 coefficients. Power 2, 3 coefficients. 4 coefficients. Power 4, 5 coefficients. That means power 5, you'll be having 6 coefficients, and so on and so on. We also remind ourselves of the pattern that when you're expanding the first term to be the same as the power you're expanding it, and keeps on reducing by 1, eventually it's power 0. The second term is being expanded from 0, so don't write it there, but then it increases by 1, then by 1, that's power 2, then by 1, power 3, then by 1, power 4, and that will be the maximum power that we're going to have here. So from the coefficients that we do have here, we have noticed that there is a pattern being formed, and this pattern was discovered by a famous mathematician called Pascal. So we're going to show here how do you come up with Pascal's triangle of coefficients for binomial expansion, and then we're going to use that one to expand terms without necessarily working them out in a long way as we did in our previous lesson. So let's come up with the expansions that we do have. We saw that if we're expanding it by power 0, there is only one coefficient, and that one coefficient is 1. When you're expanding by power 2, there are 2 coefficients, by power 1, there are 2 coefficients, and they are 1 and 1. So when you're expanding it to power 2, there will be 3 coefficients, and this one power 1, 2, and 1. If you remember, a plus b squared was a squared, coefficient is 1, plus 2ab, coefficient is 2, plus b squared, coefficient is 1. Now already, as you can see here, we do have a triangle. This is the shape of a triangle. And that's the triangle discovered by Pascal. And this is very interesting what you notice. That when you expand by power 0, it is 1. When you expand by power 1, you have 1 and 1. Then from there, to get the next ones, the first term will always be a coefficient of 1. As you saw from our previous examples, it's always coefficient of 1. Then, what is 1 plus 1? 1 plus 1, 2. 1 plus 0 is 1. If you are expanding it to power 3, we say there will be 3 terms. Now those 3 terms are, the first coefficient is 1. What is 1 plus 2? 3. As we saw in expanding it to power 3. What is 2 plus 1? It's 3. Then 1 plus 0 is 1. If you remember, when you're expanding it to power 3, it was 1a squared plus 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. You can see now the coefficients that we had initially underlined in green are coming up here. Then, when you're expanding it to power 4, we say that when you're expanding it to power 4, there should be 5 coefficients. And we say which was 1, 4, 6, 4, and 1. How did Pascal discover that? The first coefficient is always 1. So 1 plus 0 is 1. The next coefficient will be 4. 1 plus 3 is 4. The next coefficient when expanded by power 4 is 6. 3 plus 3 is 6. The next one is 4. 3 plus 1 is 4. And the last one will be 1. So when you're expanding a binomial expansion to power 4, a plus b raised to power 4 should be a power 4 plus 4 a power 3b plus 6 a power 2b squared plus 4 a b power 3 then plus 1 b power 4. Again, as you can see, it is a triangle, sort of Pascal's triangle. Now let's see if we can form. We didn't expand our term to power 5, but let's see if we can prove we can get the coefficients when you expand to power 5. So from here, and that will be our very good example we're going to use. So from here, 1 plus 0 should be 1. Then 1 plus 4 should be 5. 4 plus 6 should be 10. 6 plus 4 should be 10. And then 4 plus 1 should be 5. And the final expansion coefficient should be 1. Okay, no space there, but it's coming up with that triangle. So if you were to expand a number to power 5, the first coefficient is 1, the next is 5, then 10, then 10, then 5, then 1. And all of these are being found in Pascal's triangle. Again, an interesting thing to note here. When you're expanding to power 5, the second coefficient is 5. When you're expanding to power 4, the second coefficient is 4. When you're expanding to power 3, the second coefficient is 3. When you're expanding to power 2, the second coefficient is 2. When you're expanding to power 1, the second coefficient is 1. Very interesting pattern. Now from here, you can even know what should be the coefficients for power 6. 1 plus 0, 1. The second one we said should be 6. If you equate power 6, it should be 6. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. And then finally 1. Again, the interesting thing to note is that the second last one should be the same as the power. When you expand to power 6, the second expansion coefficient is 6. The second last is 6. When by 5, the second is 5. Second last is 5. And it goes on and on and on and on. Eventually, you see a pattern. From 1 to 4, it's an increase. From 4 to 6, an increase. Then it comes down to 4, as it was here, then to 1. Or if 5, then 10, from 1 to 5 to 10, then to 10, it's like a plateau. From there it goes to 5, then 1, it is now reducing. When it's 1 power 6, from 1 to 6, 6 to 15, 15 to 20, then it's coming down, 20 to 15, 15 to 6, and then eventually to 1. So, let's note these expansion coefficients for 5. We have 1, 5, 10, 10, 5, and 1. 1, 5, 10, 10, 5, and 1. 6 coefficients. So if you were to be given this term, you don't have to go through it the long way, the way we did in our previous lesson, to expand the term. If you are asked to expand the term a plus b equals 6. Now what is on the board here? A plus b raised to power 6, raised to power 5. Based on what we know about the coefficients here, we can work that one out. This one should be 1, because of the first term, 1 a power 5. 1 a power 5, because we know that this one should be raised to the same power. And then the next one should be b power 0. Plus, because what you have here is a plus. Coefficient is 5. 5 a power 4, because this one reduces by 1, while b will be b power 1, it increases by 1 from 0. Plus, because it was plus here. The next coefficient is 10. 10 a power 3, b power 2. Plus Next one is 10. 10, a power 2, b power 3. A is reducing, b is increasing. Plus, next coefficient is 5. 5, a power 1, b power 4. Plus 1, a power 0, b power 5. Again, because of the coefficients that you already know, we have indicated them here. 1, 5, 10, 10, 5, and then 1. It is increasing, plateaus, then goes down. The power for A from a maximum of power 5 all the way to power 0. And for B from power 0 all the way to power 5. So to remove what is not necessary here, this will be A power 5. 1 not necessary, this b power 0 is 1, not necessary, plus 5 a power 4 b, again the power 1 is not a must, you already have it there, plus 10 a power 3 b squared, plus 10 a squared b cubed, plus 5 a b power 4, power 1 not necessary here, plus 10 plus b power 5. 1 is not necessary. If this was minus, we'll have a plus here, minus, plus, minus, plus, minus. And that is how you deal with the expansion for power 5, which we don't look at in our last lesson. Once you know the coefficients, the rest is easy. So we have looked at this lesson what we mean by binomial expansion, expanding a binomial term by a given power. We have made Pascal's triangle, and we have used Pascal's triangle to work out this question. So see you in the next lesson as we'll have more of the application bit of the topic of binomial expansion.